Hello friends, today I'm going to explain about chemical properties of carboxylic acid, which involves cleavage of COH group. Means I'm going to take such a chemicals into the carboxylic acid, which breaks this COH bond. The bond between C and OH is broken. Such a chemicals I'm going to add, like alcohol I can use, like a PCl5 PCl3 SOCl2 I can use, or I can use ammonia also, or I can use any same type of carboxylic acid also. In all these things we have different types of products, but whatever the type of product, the logic is breaking the bond between C and OH only. Let's see each and everything. Let it be A, B, C, D. Let's see each and everything. First one is the most important one. Let's say, let us take first one, carboxylic acid with alcohol. Carboxylic acid with alcohol. It is very important reaction. We call this as esterification. Why it is called esterification, we are going to see further. Now let's see this. In this case, I am going to take a simple carboxylic acid. I am going to add alcohol, a simple alcohol CH3OH. These two on reaction with concentrated H2SO4. The simple thing is cut OH from carboxylic acid, H from alcohol. The answer is very simple. Write a CH3 bond CO. This carbon is losing the bond, so here oxygen is losing the bond. So between this carbon and this oxygen, a new bond is formed, and the side product is water. H combines with OH and forms H2O. So this is a chemical that is removing that water. So it is called a dehydrating agent. Dehydrating agent means the chemical which removes water from the chemical reactions is said to be dehydrating. Hydrating means addition of water. D means removing of water. Okay. Now whatever the function group I got, it is like a ester. Ester general formula is RCOR. RCOOR. RCOOR. In that sense, it is ester. As ester is formed, it is called esterification. So when carboxylic acid is reacted with alcohol in presence of concentrated H2SO4, we get ester plus alcohol. As ester is formed, we call this as esterification. Now in this reaction, we have to see mainly mechanism. So mechanism is the main one. So what happens in this reaction is, the first one is, this carboxylic acid will be like this. It is reacted with, first it is reacted with acid. This concentrated H2SO4 gives H plus ions. So this H plus ions plus requires minus. That means in fact electrons. Wherever electrons are more, their hydrogen will attack. So actually between carbon and hydrogen, it's a double bond. So electrons density is more. So H plus attacks on that oxygen. Now see carefully, CH3C double bond O. Now this oxygen is forming a bond with hydrogen. It gives its own electron pair to hydrogen. So it is losing electrons. So it is a plus. Remaining oxygen is like this. Okay. Now the thing is, oxygen is with a positive charge. It requires that electron pair back. So it will try to take electrons from carbon because oxygen is more powerful than carbon. So it takes electrons. If it is taking electrons, carbon is losing. So carbon gets positive charge. So to rectify this alcohol, whatever the alcohol we have taken, CH3OH is a chemical we have used. That alcohol which contains oxygen has an electron pair. That alcohol with electron pair attacks on the carbon because carbon is in need of electrons. Now the thing is CH3, C, it is no single bond only. Why? Because oxygen taken electrons from carbon, that is why 2 electrons it got. Now it is single bond. Here also OH single bond only. Now this alcohol attacked. From alcohol also oxygen is attacking that. So oxygen, one side hydrogen, one side CH3. Now oxygen given its own electron, so it is losing, so it is a plus. I think up to here it's clear. I'm repeating once again. Let's see this. Carboxylic acid structure is like this. We have 2 oxygens with 2 electron pairs. The acid like H2SO4 releases H plus ions. H plus ions attacks on one of the oxygen. Mainly it attacks on the double bonded oxygen because it has more electron density. Oxygen has to donate its own electron to the hydrogen. So it is losing electrons, so it is a positive charge. So to nullify that, it takes electrons from the carbon. So as carbon is losing electrons, it gets positive charge. It attracts a negative from the substance. So in a solution, we have alcohol. Alcohol contains oxygen, which contains electron pair. This electron pair is attacked on the carbon. That is why oxygen forms carbon bond with carbon. Now electron donated its own electrons to the carbon. So it lost electrons. Now the case is, see carefully. CH3, C, one side OH, other side OH. I'm writing OH up, it doesn't matter, we can interchange positions. Now O, one side H, one side CH3. If you observe this oxygen with a positive charge, it attracts electrons from hydrogen. Oxygen is more powerful. To get its own electron pair, it attracts electrons from hydrogen. So this hydrogen is removed as H plus. This H plus attacks on the one of the OH. Because oxygen has electron pair here. So we can write like this. This H is removed. So it is, this O is with CH3. Now it's okay with the 2 electron pairs. But this oxygen is accepting, giving electrons to hydrogen. This H plus attacks on that oxygen. So it is giving its own electrons, so it is a plus. If you observe this, oxygen has positive charge with 3 bonds, which is not stable at all. So it attracts electrons from the carbon. So when it attracts electrons from the carbon, so it is removed as water, H2O, 2 hydrogens with 1 oxygen. Now carbon is there. Now carbon is there with a positive charge. It is losing electrons now. To satisfy this oxygen has 2 electron pairs. Okay. This electron pair is given to this carbon, so that it forms double bond with oxygen. This carbon forms a double bond with oxygen. But oxygen has two, it has to possess two electron pair, but only one electron pair is there, as it given its own electron pair to the carbon. So it lost it. So it releases that H plus because it pulls that electrons from hydrogen. So H plus is removed. Minus, I'm going to keep minus here, which removes, indicates removing CH3, C double bond O with two electron pairs with OCH3. So it is ester. It is ester. Now let's see this. Each and every step we have a different names are there. Here proton is transferred from one place to other place. So it is called proton transfer. Proton transfer happened here. Next here water is removed in this step. Okay. Now this part, actually it is ester. This part is totally ester, but hydrogen is there, which means H plus proton. So it is called protonated ester. This whole part is said to be ester. On this H plus is there, so it is called protonated ester. H plus is nothing but proton. This is your real ester. So this is a mechanism of esterification. I am repeating the mechanism once again. Carboxylic acid is there. H plus acid attacks on the oxygen with the electron pair. So oxygen with positive charge pulls electrons from carbon. Carbon gets positive charge. So from alcohol, oxygen attacks on the carbon with electron pair. Oxygen lost its electrons, so pulls electrons from hydrogen. Hydrogen removed as H plus. It is migrated to other oxygen with electron pair. When it moves there, now it oxygen with positive charge is there. So it needs one more electron pair. So pull electrons from carbon. Again, this carbon is positive charge. To satisfy this, oxygen gives its own electron pair. That is, oxygen gets positive charge. To satisfy this, again it removes electrons from hydrogen. This hydrogen is removed. At last, we got ester. This is a story of esterification. Thank you.